Okay, so today we're going to be graphing polar equations, and to do a graph we have to plot points, and if we're doing the graph of a polar equation, that means that we need a polar coordinate system. So I'm going to do my best to draw one out. In the meantime, you should be doing the same thing in your notes and copying down everything you see on the slide. So I'm going to make sure that I ask you to pause it so you have enough time to do all of this. And then I'm going to also pause mine to draw out my graph. Okay, so you're going to see that this is traditionally what we use for a polar coordinate system. And you can also include the angles where you're going up by pi over 4. I did not do it for this particular problem because it's not necessary to have those extra points, but sometimes it does help with your graph, so you're more than welcome to put them in if necessary. You're going to see in my table I did not include pi over 4, and part of the reason is because in your graphing calculator, it can help you fill out the table instead of just doing it by hand. So let's actually address the first step here. So to fill out the table, of course, we can take all of these angle measures, okay, that we're labeling in our polar coordinate system anyway, and plug it in for theta so we can figure out r. Okay, and so with that, I can plug in 0, sine of 0 is 0, 0 times 4 is 0. So you can get the answers that way, and you can do one by one. But you can also do it in the graphing calculator as well. And that's, if you want to do it by hand, you can also do the pi over 4, the 3 pi over 4, the 5 pi over 4, etc. in your graphing calculators as well if you ask it. But this we can do automatically. Also, you can do these by hand. All right, let's skip that because I want to stick to just getting the idea of our graph here and our table. So, like I said, you can do this in a graphing calculator, and I'm going to show you in a second what that would look like. So you can see instead of changing from function to PAR for parametric, we're going to go to POL, which is for polar. And you're going to now put in your R equation. When you hit the variable key, it'll come up as theta. Okay, you can see that it's a little bit blurry, but I was able to put in that clip. I'm sorry you saw it kind of underneath the graph there. I thought I had stopped the video. Oh well, let's move on. Okay, so now it doesn't look as silly. I'm putting in the table setup. You want to start at 0, go up by pi over 6, which is basically what we see in our polar coordinate graph. And, okay, so you can see the table. It does go up by pi over 6, so you have to kind of keep track or be familiar with some of these values. Like half of pi is about 1.57, so you know pi over 2, what its answer is would be 4. So when you're filling out the table, try to just keep in order and it will help you immensely. So we started filling out the table. Yes, the value is 0 for r, and then it's 2, then it's actually, if we do this by hand, it's 2 radical 3 here, which 2 radical 3 is approximately 3.4641, okay? And again, you can kind of see that in the calculator. At pi over 2, it's 4. 2 pi over 3, it's that answer again of 2 radical 3. 5 pi over 6 is 2 at pi at 0. And you have to actually keep going down in your table. I'm not going to show that to you, but I will write out the values. We get negative 2. We get negative approximately negative 3.4641. And then we get, for 3 pi over 2, negative 4. At 5 pi over 3, we get that negative 3.4641 answer. Then we get negative 2, and we're back at 0 for 2 pi. 2 pi is about 6.28, so don't go beyond that in your table. And now we get to plot all of these lovely points and connect them. The key thing is to connect as you go. If you start to put, 13 points, you're not going to know how to connect them in the ends, and it's not going to be the correct graph. This isn't as easy as doing a straight line or a parabola. You know what it looks like. You don't know what these look like just yet. So please plot and connect. And we always connect with a curve because it is trigonometric, and our curves always go counterclockwise, okay? So keep that in mind as you're connecting them. So here we go. I'm going to start with our first point, and it is at the pole. Then at pi over 6, r was 2. I'm plotting that point, and then connect as you go. And you see how I'm making a curve, but I'm connecting from one point to another, so it looks like it's concave up. All right, here we go. We're going to go to the next point. Pi over 3, r was between 3 and 4. 1, 2, 3, 4. And connect as you go. Pi over 2, it was 4. Connect as you go. 2 pi over 3, again, it's that funky number. Connect as you go. Okay, then it was at 2, so 5 pi over 6, it was at 2. I'm kind of trying to meet it where it's supposed to be. Connect as you go. And at pi was 0, connect as you go. We actually made a circle. I know it doesn't look like a great circle on my graph, but if you have that graph paper I gave you, it would connect nicely and it'll look more like a circle. 7 pi over 6, so if we're at the pole and we go to 7 pi over 6, but r is a negative 2, we actually start retracing this circle. You don't need to, but as far as plotting all the points from 0 to 2 pi, it would end up retracing it again. Okay, just to let you know that, I'm just going to keep going. Okay, at 4 pi over 3, it was that negative 3.4641, and at 3 pi over 2, it was negative 4, and at 5 pi over 3, it was negative 3.4641, and at 11 pi over 6, it was negative 2, and then at 2 pi, it was the pole there, and connect. So there we have it. That is our graph, and that's how we do it. Take one thing at a time, follow your table. So we actually did this part here. The next thing is answering questions. Where's the R max? Where are the zeros if you're asked? We weren't really asked it in this problem. Your R max is your largest R value. You may need to take the absolute value. So in this case, okay, if I take the absolute value of any one of these, it is 4. So your R max is 4. And zeros is actually where R becomes 0 and you solve. In this particular one, we can kind of see the answers in our table. This is when sine of theta is equal to 0. So obviously the answers here are 0, pi, and 2 pi. Okay. Other problems, it becomes another trig equation to solve, but this one you can kind of see it in the table, so it worked out nicely. All right, so keep practicing, keep working on it, and good luck.